Okay, so what I'm going to do now is to start changing the downstream temperature. I'm going to, downstream pressure, sorry. So let's start from 0. For 0, I'm just going to look at this box. So the answer is what? Oh, 64. That's the. Okay, see for 0, you see it's subsonic of it's sonic flow. So if it's 0, it's sonic flow. So that's why it's the maximum there. So I'm going to create a table there. Let me create a table. Q and P, just as we used to do. Now I'm going to change the P from 0. I start from 0. Let me do increment of 10 because I'm going to what? 100. I'm going to run all of them. So this one doesn't waste time. You can use any increment for yours. So for 0, the answer is, just going to copy this. I'll paste value there. Paste value. Okay. I know it's going to be the same thing until I get to the critical pressure. The critical pressure is going to be, okay, the next one is 10. It's still going to give me the same answer. Because you see, it's 64.78. The next one is 20. It's still going to be the same thing. If you check here, we are still in sonic flow. You know, when you are in sonic flow, the flow rate is the maximum. It doesn't change, whether you change the downstream pressure or not. So 30. And what you should be checking, you see the temperature is changing. I forgot. You see, when I put at 30, although the flow is still the same, but the temperature is changing. Okay, yeah, because it's sonic flow now. Sonic flow is very fast, so it's going to be very cold. So this all the sonic flow is going to give me 11.11 Fahrenheit. Then when I change to subsonic, it's going to be 46. You just wait and see. 40. I'm sure I'm still in the sonic region. See, it won't change. So the sonic temperature is 11.11. So it's still the same. 50. It's still the same. So it means we haven't reached the critical pressure yet. It is at the critical pressure that is going to change. 60. Oh, okay, now it has. Oh, it's still sonic. No, it's changed. Okay, see, change. Now it's less. So let me copy this. Now we have shifted to subsonic. You see, it's 0 here. So it means the critical pressure is between 50 and 60. And that's part of what I asked you to calculate. Actually, the critical pressure is the critical pressure ratio multiplied by the upstream pressure, which is 100. So it's 100 multiplied by 0.55. So the critical pressure is 55 point. You see, if I put 55.4 something there, that's when it changes. So 70. 70 is, I copy that. For this lab, I will let you do your graph in the template, okay? You don't need to do another, because you have to turn in the template. I want to see the template. I don't want you to turn into Excel files. So I'm going to allow you to do your graphics in this. Okay, 80. is 5462. I copy that. See, keep going down. Just as we did for IPR, it's still the same concept. If the downstream pressure equals 100, which is the last one, it means there's not going to be any flow. If the pressure are the same, the upstream and the downstream, you see, this one should give me 0. Okay, you see it's 0. Okay. The temperature here is, oh, I missed something. Okay, I have to start. I missed 90. This is 0. And I didn't record my area. Let me go back to area. $54.62. I'm going to copy. Paste value. 90. You see that the curve is going to look like the IPR curve too. 90 is 41, 48. One thing you notice now is the temperature. If you look at the temperature, oh, I didn't show you that. In the subsonic region, after you cross the critical pressure, you see that the temperature keeps changing. It keeps getting increased because the flow is no longer steady. But within the critical zone, when the flow is choked, that's below the critical point, the temperature is constant. It's 11.11. Just see your own case. You just check. You still find out that the temperature only starts to change once you get to the subsonic, after you cross the critical pressure. Okay, now I got my data. This is what I'm going to do. I'm going to highlight all of them. Then I'm going to do insert. Scatter. You do the same thing as you've been doing. Where is the chart? Okay, here is the chart. You see? Looks like IPR. But the thing is, you have a vertical line here. That point here where it starts to be vertical, that's the critical pressure. And it's going to be 55 point. Okay, I asked you to find the critical. What is the critical flow rate? The critical flow rate is the highest flow rate, which is 64.78. That's when the flow is sonic flow. So the critical flow rate, which is what you call AOF in IPR, that's that value there, 64.78. Then the critical pressure ratio, which is the critical pressure is the critical pressure ratio, which is 0.55. Let me do it here. Critical pressure equals, I'm going to calculate it here. So I'm going to do equals what? What is the critical pressure now? Equals my critical pressure ratio multiplied by the upstream pressure, which is 100. So what it means is it's at this pressure that it changes from sonic flow to subsonic flow. So I expect you to do the same thing in your lab.